So capillary action is how water is able to move upwards in plants. So it can move from the roots of a plant up to the stems and leaves of a plant by use of cohesion and adhesion. Okay, now cohesion, thanks for that, Kat. I guess we have a helper here. Cohesion is water sticking to itself. Adhesion is water sticking to other objects. So they kind of work together and it can move its way up. So in these cups here, I just have water filled up to the top with one, and then an empty cup in another, and then a paper towel connecting the two. So the water has already started moving up to one of the paper towels, and if I leave it here long enough, I really don't want your butt in my face. If I leave it there long enough, eventually the water levels will equal out. So let's go ahead and we'll come back in like an hour or two and see how it looks. All right, guys, about an hour later, as you can see, we're about, got a little bit of water there in the bottom, not a whole lot, but again, the whole idea is you can see how it works its way up and down. So water is able to move itself up by grabbing onto the paper towel, sticking to itself, grabbing on, sticking to itself, all the way up and over the side, and then eventually it's going to equal out. That's all there is to it. That's all. See you guys at the next one. As our next property of water, we're going to talk about cohesion and adhesion. They kind of go together. But so adhesion is how objects can stick to other objects of a different kind. Cohesion is how water or any objects of the same kind will stick together. So water specifically is what we're talking about. And this can be demonstrated really easily. Water droplets are going to stick together and make bigger droplets. So we can go ahead and put several drops of water on a penny, and you notice that it kind of bubbles up in like a little dome until eventually it will break. But I'm just going to go ahead and put however many drops I can get on there. And then I'm going to repeat it with some soapy water. And the reason I'll do it with soapy water after is because the soap will reduce the cohesive strength of the water, so it won't bubble up like that. It won't form as many drops won't fit on there. So let's go ahead, and this is a rather large dropper. You can use a smaller one and fit even more drops, but let's go ahead. 10, 11, 25. Isn't broken yet. See if we can get another one. 20 and 30. All right, now we're gonna go ahead and repeat it with soapy water. Remember, soapy water is gonna reduce the cohesive strength of water, so it's not gonna stick to itself as well. So we ended up with 34 drops on the regular water. Now we're gonna go ahead and do the soapy water, see how many we can get. It's already starting to fall off. 14. So less than half of what we did with the regular water. All right, guys, so I'm gonna do a quick demonstration of properties of water. So obviously water can be a solid, liquid, or gas. Okay, I got some ice there, we got an ice bath. I got an empty can of soda, not completely empty, there's just a little bit of water in there, which is pretty much all steam. So what we're gonna do, I'm gonna go ahead and take that can with a little water in there, I'm gonna flip it over in the ice bath. And what's gonna happen, because that steam that's really hot in there, that can's gonna cool really quick, and essentially it's gonna make a vacuum, and there's no way for the air to escape. So ultimately, if done correctly, the can will basically crush itself. So let's see what happens. Let's test it out. It works. It works.
Okay.
Good. All right, guys, so we're going to demonstrate another property of water, which is high specific heat or high heat capacity. Basically, that means water is really good at resisting temperature change. So this is really good for, like, if there's a heat wave outside, the temperature of the ocean doesn't just jump up to 90 degrees. It resists that temperature change. It's a very simple way to demonstrate this. I got a balloon with just a very little bit of water in here. And if you go ahead and put a lighter under there, it doesn't pop right away. It takes a little bit longer. So I got a couple volunteers, some of your teachers here. that's gonna help me do this, and we're gonna, I guess it's kind of like a little game, and we're gonna see how long it takes before the balloon pops. So let's go ahead and get started. So, how should we decide when I move to the next person?
Yeah, big question. I just
Don't you burn my hair.
How about you count to 5 Mississippis and I'll move to the next one.
1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
Should we do 10 seconds now?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
Alright, now I guess we'll do science questions. How about...